3.1 Combinations and problem solving with combinations. So a combination is a selection of R items from a set of N items. So when is it used? It's used to determine the number of possible arrangements in a collection of items where the order does not matter. Okay, so Unit 3, order does not matter. Really highlight that in your brains. Unit 2, order mattered. So there's no hierarchy and no assigned roles. It's just like a group of individuals or kind of like a subset. Okay, so examples of this in real life, or maybe where we're going to see them in this course, is choosing members for a committee where it's the same job. So again, no hierarchy of roles like vice president. It's just the same job. Okay, lottery tickets, if you think about like Lottery 649, it doesn't matter in what order you choose the numbers as long as you choose them. So it's just a subset, right, of say 649, 6 numbers out of the 49. Okay, menu options, doesn't matter if you order 3 appetizers, there's no order or hierarchy of it. Okay, so let's do a mini investigation. Suppose you need to choose 2 individuals to be on a committee out of 5 individuals. So we have Sarah, Jane, Petra, Nikki, and Roberta. List all combinations, so possible subsets of different committees that could be made from these individuals. Okay, so there could be Sarah and Jane, or they could be Sarah and Petra, or we can have Sarah and Nikki, or Sarah and Roberta. Okay, so Sarah has been matched up with everyone. We don't match her up again because remember, there's no roles. So Sarah and Roberta is going to be the same as Roberta and Sarah. Okay, so we can have Jane and Petra, Jane and Nikki, Jane and Roberta. Jane's done. We can have Petra and Nikki, Petra and Roberta. Petra's done. And then we can have Nikki and Roberta. And Nikki's done. And Roberta's actually done because there's nobody else to match her up with. And we've already matched her up with all 4 other individuals. Okay, so the total number of ways that we can do this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 ways. Now, listing those subsets is very, very tedious. So we're going to find ways to do this with algebra. Okay, so combinations of n distinct items taken R at a time. That's what it's actually called. So the combination of R items chosen from a set of n distinct items as a grouping with no order. Okay, so when we choose a group from the universal set, we use one of the 3 combination notations. So we can see this as n choose R, okay, subscript n, nr. We can see this as the choose function and then n comma r. Okay, this is easy to put into a computer system, so you might see that. Or you can see n over r, but there's no division symbol. So just be aware of that, okay? It's just n over r. So you're going to see that 3 different ways in like textbooks and in university. So this is all 3 of these are equivalent. They're all called the combination formula, or we're going to just refer to it as the choose function. So the n choose r, this is how we expand the equation. And essentially what it comes down to is it is NPR over R factorial. Because what we would be doing is like we would take every single possible way to order them, but then we would divide out duplicates, which is that R factorial. We know that this here is the permutation equation, and this all just cancels out to this equation here. Okay. Most of the time, we will not use that, and we will just use n choose R. So we're going to redo example 1 using the combination formula. So there were 5 individuals, and we had to choose 2. So this is going to be the total number of people, and this is going to be the number that we choose. Okay, so in your calculators, if you put in 5 choose 2, you're also going to get 10. Okay, let's apply the combination formula. So determine the number of different 3-flavor ice cream cones you can get from an ice cream shop with 25 different flavors. So we're going to do this 2 different ways. We're going to do this using the combinations formula, and then we're going to use it with NCR. So NCR is the easiest way. Even if you want to start, okay, we have 25 flavors, and we're going to choose 3 of them to be in our ice cream cone, right? And the flavors are going to be different, so that's easy. So 25, choose 3. We're going to get a big number. There are 2,300 different ice cream cones that we can have 3 different flavors, okay? No, order doesn't matter. It doesn't mean that you want the most tasty one first or the most tasty one last, okay? So this is total flavors. And this is how many we're choosing. Okay? But the actual combination formula, remember from up here, it's n factorial over n minus r factorial. So n factorial over n minus r factorial. So this is simply 25 factorial over 25 minus 3 factorial, and then 3 factorial. If you actually think about 25 minus 3, this is going to be 22 factorial, 3 factorial. Let's actually expand this part of it, okay? So 25 times 24 times 23 times 22 factorial. And that 22 factorial can get rid of the 22 factorial in the denominator. From this, it's much easier to work with. And if you just put this into your calculator, we're still going to get that 2,300. So these 2 you're going to use, they're going to equal the same. We're going to focus more on the choose function because it's much shorter. And why not use our calculators if we can? Okay, so let's expand on this. Combinations and the fundamental counting principle. So as a recap, the fundamental counting principle is when we have more than one event occurring under the scope of one thing happening. So one event, okay? So like different stages. How many different ways can a 3-course meal be ordered from a menu of 5 appetizers, 4 entrees, 3 desserts? Okay? We're not going to use a tree diagram. We're just going to go straight to the choose function. So a 3-course meal essentially has 1 app. Okay, then we have 1 entree. We're going to multiply these, and then 1 dessert. Okay, so this is how we do this with the choose function. We have 5 apps, and we're going to choose 1 of them. Times, there's 4 apps, and we're going to choose 1 of them. And there's 3 desserts, we're going to choose 1 of them. And if we actually put this into our calculators, we actually get 5 times 4 times 3. Okay, so we get 60. 60 ways to choose your dinner, your 3-course meal. Okay, so this is when this is all one meal. All one meal. Okay, so these things are happening at the same time, so it's multiplication. Okay, let's take a look at an example where we use different cases. So Petra is planting a garden. She has 14 flowers, 8 shrubs, 2 trees to select from. And how many ways can she make her garden if she wants it to consist of? So this is one combination. 4 flowers, 2 shrubs, 1 tree. So simply, we have 14 flowers, we're going to choose 4 of them. We have 8 shrubs, we're going to choose 2 of them. And we have 2 trees, we're going to choose 1 of them. So expand this, you're going to get a big number. I'm okay with the equation right now. This is the equation for the number of ways that she can make her garden. 4 flowers, 2 shrubs, 1 tree. Okay, so we saw this in the previous question. Now, What about B? Either 4 flowers or 4 shrubs. So these are different cases. Case 1 and then case 2. And we're going to add the different cases because these are not happening at the same time. So the way she can choose 4 flowers is 14 choose 4. And that can be her garden. Or 4 shrubs. So there's 8 shrubs, choose 4. Okay? So there's 2 different cases and we add those. Okay. A band plays a variety of songs. They play 4 jazz, 5 hip hop, and 7 oldies. In how many ways can the band choose 3 songs for an assembly if there's no restrictions? So, if there are some identical items, what we want to do is we want to do different cases, but we want to regroup. So, no restrictions, okay? The total songs, if you think about it, is going to be the 4 plus 5 plus 7. So that's 16. So in general, if there's no restrictions, it's just 16, choose 3. That's it. Okay, so there's 16 choose 3 ways of randomly selecting 3 songs. Now, what if we have to have at least one oldie song? So case 1 is 1 oldies. Okay, plus case 2 is 2 oldies. Plus case 3 is 3 oldies. As long as there's at least one. So here's how we're going to regroup. We have 7 oldies. We have 4 jazz, 5 hip hop. Here's the thing. We don't want to sit there and be like, okay, 1 jazz, 1 hip hop, 2 jazz, 0 hip hop. Like, there are too many scenarios to add it to like 3 different songs. And so what we're going to do is we're going to collect those and we're going to call them, we have 9 non-oldies. So oldie complement. So we're going to group these ones together. So if we have 1 oldie, we have 7 oldies, choose 1. Then we have 2 songs left. So we have to choose 2. And it's going to be 9 choose 2. And take a note. However many we're choosing, 1 and then 2, this adds to 3. We've chosen 3 items, 3 songs. Now, 2 oldies, 7 choose 2. Which is going to leave us with 1 non-oldie. And again, the 2 plus 1 is 3. Now what about 3 oldies? That means we're actually choosing no non-oldies. So 7 choose 3 and then 9 choose 0. And again, those add up to 3. Okay? And as like a little bit of a tidbit, the 7 and 9 add up to the universal set. Okay? So, number in the universal set, and then that's the number that we've chosen. All right. 2 more questions. Interpret a diagram. 7 points represent cabins at a lodge. How many paths can be drawn by joining pairs of cabins? So, pairs are 2. That's what a pair is. And if you think about it, we have to join 2 of these nodes or 2 of these cabins in order to get like a pathway or a road. Okay? We can't join A to itself. So we can join it to B, C, D, E, F, and G. So if you think about it, the total number of cabins is 1, 2, 3, 4, 5, 6, 7. So we have 7 cabins, and we want to know how many subsets are there of 2. So as long as we're choosing 2 items or 2 cabins, we can connect them. So there's 21 different paths. There are 21 possible paths. Okay. Last one, this is a little bit higher order thinking because what we're going to do is we're going to choose and then we're going to arrange them. So this is taking into account like the choose function. So how many different ways are there to choose something? But then arranging is permutations. So then once we choose it, how can we actually line them up? So Christina has 9 family pictures. I'm just writing down my givens, and 7 friends pictures. Okay, that she wants to display on a shelf. Her shelf is able to hold 4 family pictures, so we have to choose 4 of these, and it can hold 3 friends pictures. So we're going to choose 3 from the friends. Okay, so already in my head, I'm thinking, okay, 9 family, choose 4 of them, times 7 family, choose 3. So that's what I'm thinking if we have all of these pictures and we just want to choose them. But in the question it says, how many ways can Christina select, which is this equation, then arrange the pictures on her shelf? Okay, so if we want to arrange these after, well, how many pictures do we have? 7. So once we choose them, so there's this many ways of choosing them, 9 choose 4, 7 choose 3. Now we're going to take those 7 and we're going to arrange them. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so what we're going to do is we're going to multiply this by 7 factorial.